All right, guys, you're welcome to another exciting moment here with us. My name is Mr. Chooks. So we're going to be doing something very different in this video. I have some of my students, they are in high school, and they are sending some of their questions to me so that I can help them explain it and so they can understand how to go about the solution. All right, so that is exactly what we're going to be doing in today's video. All right, so just pay attention if that is what interests you and tell me how much this video has been of help to you in the comment section. So now we just have to get started. Now, question one, it says solve the equation x squared minus 3x minus 2 equal to 0. This is a quadratic equation, and we have many ways to solve quadratic equation. You can solve it by formula method, by factorization method, by completing the square method, and even graphical method, right? But most people struggle with factorization method. They keep factorizing what is not factorizable. So let me tell you when to use factorization method. If the discriminant is a perfect square, then you can use factorization method. What then is the discriminant? The discriminant is d is equal to b squared minus 4ac. This is the discriminant, right? If you can get a perfect square from this, then you can solve by factorization method. So now, how do we get our b and our a and our c? We get that from this equation given to us. Remember, quadratic equation is written in this form, in standard form as ax squared plus bx plus c. This is how we express quadratic equation. So when you compare this standard form and the equation given to you, you can always find your a, your b, and your c. Now you can see that your a is a coefficient of x squared. And what's the coefficient of x squared? Yeah, that's going to be 1, right? So a is just going to be 1. So a is going to be 1. Then my b is the coefficient of x. What's the coefficient of x here? You can see that is just -3. So b is going to be -3, right? You want to pick the numbers and their signs. Then my c is a constant term. So what's the constant term here? That is going to be -2. So c is -2. Now you have all of this information. You can just plug them right here and see what the discriminant is. And b is -3. That will be -3 squared minus 4. Our a is 1 and c is just -2, right? Now -3 squared is going to give us +9. And -4 times 1 is -4. Then -4 times -2 will give me +8, right? Yeah, minus times minus is negative. So 4 times 2 is 8. And 9 plus 8 is going to give me 17. 17 is not a perfect square. So we cannot solve this equation by factorization method. All right. So if we had gotten something like 16, for example, if we had something like 16, 16 is a perfect square now because 4 squared is 16. Then we can now solve this by factorization method. So because we don't have a perfect square, this cannot be solved by factorization method. So we can use formula method to solve it or completing the square method to solve it. I already have videos on the channel that will teach you all of this method, okay? But here, I'll just show you how to solve this one by formula method. Now, what is the formula? The formula is simply, since this equation depends on x, so I can say this is x1, 2 is equal to minus b plus or minus the square root of b squared minus 4ac, right? All divided by 2a. We already know all of these, guys. We already know what is our a and b and c. So we can just go ahead and plug them into that equation. So we have minus. Our b is already -3. So this is the minus we have in the equation, in the formula. And b is -3, right? You see, I have to put that in bracket. Then plus or minus the square root of b is -3 again. But this time it is raised to a power 2 minus 4. A is 1 and c is -2. So you go ahead and simplify. Remember, all of them was divided by 2 times a, which is 2 times 1 because a is 1. Now, -3 is going to give me +3, plus or minus. -3 squared is 9. Then minus 4 times minus will give me +8, right? All divided by 2 times 1 is 2. And back to this side, we have 3 plus or minus square root of 17 all over 2. So finally, we can say x1, this is like x1, 2. That's why we have x1, 2. Just like we can have our x1 and we have our x2 from there. So x1 is going to be 3. We take one of the signs. Let's say 3 plus square root of 17 over 2. And x2 is going to be 3 minus square root of 17 over 2. You can leave your answer this way, Or you can still use a calculator to simplify further. Get the square root of 17, add it to 3, divide by 2. That will give you your x1 in decimal. Then get the square root of 17, remove it from 3 and divide by 2. That will give you the answer in decimal, and that is x2. So any of those ways still work, but if you can use calculator to simplify further, that will be fine. So that is it for question 1. I hope this is really clear. If it's clear, please let me know in the comment section. All right, let's go to question 2. Now, this one says factorize the equation 4x squared minus 11x equal to 6. I quickly want to write it as 4x squared minus 11x then minus 6 equal to 0. Taking the 6 to the other side, so it becomes negative 6, and we have nothing in the right hand side. That is just 0, right? Okay, so before I start solving, I want to see if I can solve this guy by factorization method. You know, I taught you that earlier. So let me see the discriminant. That will be d equal to b squared minus 4ac. So b is, okay, from here, when you compare it with the general equation of a quadratic equation, general form of a quadratic equation, which is as squared plus bx plus c equal to 0. You can see my a is the coefficient of x squared, so my a is going to be 4, a is going to be 4, and b is going to be negative 11, right? Of course, you know it by now. And c is going to be what? Minus 6. Perfect. So now we have all this information. Let's plug it here. So b is minus 11 squared, and a is 4, c is minus 6, right? I'll need a calculator for this stuff. So minus 11 squared, I know that is 121. And negative is going to give me positive. So 4 times 4 times 6. I need a calculator. Okay, I have mine now. 4 times 4 times 6 is going to give me 96. So that's 96. Then I add it to 21, right? I add it to 121. Sorry, 121. That is 217. And 217 is not a perfect square. All right, so you cannot find a square root of 217. That is going to be in decimal, so not perfect square. So that means you cannot solve this one by quadratic equation. I mean, by the formula method. So we can use the formula. So you cannot solve this guy by factorization method, right? So you can use any of the other method to solve this one. All right, so that's how to go about it. You can use the formula method again to solve it, but they say factorize. So this time, let me quickly show you something. The answer we got here, x1 equal to this stuff, x2 equal to this stuff, they are called the root of this equation. All right. So when they say factorize, they don't want to give the answer in root. They want to put the answer in the factor form. So if I want to factorize this stuff, my answer is going to be like this. X, let me say this is x1. Going to be, this is the root. So I'm going to take this one inside. It's going to be like x minus 3 plus root 7 over 2, like this. Then the other one will be x minus 3 minus root 17 over 2. So this is the factored form of this quadratic equation. All right, and this are the root form, right? The root form. So that is what we want to do in the next example. I hope that is clear. So we can use the formula method to go about it. Now remember, we have x1 comma 2 is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. You have all the informations you need. A and B and C are right here, so you plug them in accordingly. So you have minus 11 plus or minus, B is minus 11, but this time it is squared. Then we have A to be 4 and C to be minus 6 all over 2 times A, which is 2 times 4. Of course, that's going to give us positive 11, minus 11 times 11. So the negative times negative 11 is going to give us a positive 11. Then we have plus or minus. We already done something like this. Remember, that's going to give us 217. So that's all about 217, right? And finally, we have upon 8. So like I told you, this is your x. And you can just write them in factored form because you cannot really simplify square root of 217. It doesn't have a perfect square root. That's the idea. So we can't do that. We can't simplify further. So we cannot say that x1 is equal to 11 plus root 217 over 8. And x2 is going to be 11 minus 217 over 8. This is in the root form, right? In the root form. Now, in the factored form, you want to bring them all inside in a parenthesis, right? So that's going to be like x. You don't need to put the x1 and x2 again, right? You just kind of put them all together. X, now when this one comes over, it becomes negative 11, right? This is like a term, so just see them as a term, right? 11, when it comes here, it becomes negative 11 plus root 217 over 8, okay? Then you have the other one like this, you have this one like this, so you're going to be x negative 11 negative root 217 all over 8, like this. So this is the factored form of this quadratic equation. All right, so that is how to go about the factored form. Then you can say equal to 0. So we have just factored this equation right now. So I hope this one is clear. All right, let's go to the next question. Question number 3. Now, this one, it says, if 2x squared minus 6x plus 5 equal to 0, then what is the equation whose roots are this and this? Now, remember, we're already given a quadratic equation, and we want to form another quadratic equation that has the root x squared, alpha squared plus beta squared, and 1 over alpha plus 1 over beta. All right. Now, I am very sure you should know that you should know the sum of a root and the product of a root of a quadratic equation. But let me show you how to go about this just with this short period of time. In the future, I'm going to make a video that will teach you how to go about this problem one step at a time. So I'm going to be doing some stuff right here. But if you don't understand, let me know. I'm going to make a video in the subsequently that will teach us how to go about solving problems like this. All right, the first thing you want to do is you want to form an equation that has this guy and this guy as the root. Now, that equation you're going to form is like this. The equation is going to be in this form: x squared minus sum of roots, then x, then plus product of roots equal to 0. That's the equation you want to form. So if you can tell me the sum of roots and tell me the product of root, I'll just plug them right inside here and get my equation, because they want you to form an equation that has this guy and this guy as the root. All right, so now since we know these are the roots of the equation, we're going to get the sum of the root and then we get the product of the root. Okay, so the sum of the root is going to be like saying alpha squared plus beta squared. Then we sum it. That's the sum of the root plus 1 over alpha plus 1 over beta, right? That will be the sum of the root. Then we'll also get the product of the root. Let me put it down somewhere here. We'll get the product of the root. That is going to be product of the root. That's going to be what? Alpha squared plus beta squared, then times 1 over alpha plus 1 over beta. That's the product of the root, right? So if I can get the sum of root, I'll just plug it in right inside here. If I get the product of the root, I'll just plug it right inside here. Boom. That's all. That's just what we want to achieve. We want to get the equation that has these guys as the sum of root and the product of root. Shikina. So, but before we start getting the sum of root and product of the root, we need to get some basic stuff. We need to get the sum of the root and the product of the root of this equation given to us already. So the sum of the root here, if alpha and beta are the roots of this equation, the sum of the roots here is going to be alpha plus beta, which is equal to minus b over a. Right, that is it, right? There are actually some ways to go about it. Like I said, I will make videos that will teach you comprehensively about this stuff. And the product of the root is going to be alpha beta, which will be c over a. So now from here, you know what your a is. Your a is going to be 2, the coefficient of x squared. Your b is going to be minus 6, the coefficient of x. And your c is going to be what? 5, right? So let us get the sum of root and the product of root of this equation given to us already. All right, so what is alpha plus beta? That's minus b over a. So what is b? B is -6. That's going to be -6. And the a is just 2. So that's going to give us 6 over 2, and that is 3. Right? So alpha plus beta is just 3. Let's box that one. Then alpha beta is c over a, and c is just 5. A is what? C is 5 here, A is 2 here, 2. So alpha beta is just going to give us 5 upon 2. So how did we get alpha plus beta and alpha beta? We got it from the equation already given to us. And with this one, we want to form another equation that has this guy and this guy as the root. That's why we are trying to get this sum of root and the product of root, and we'll plug it right inside here. You see when this and this will be useful for us in the future. You're going to see it now. So very quickly, let us simplify this guy. This is like over 1. This is over 1. I hope you know that. And the LCM for all of them is going to be alpha beta. So 1 divide this alpha beta is alpha beta. Alpha beta times alpha squared will be what? The alpha will multiply itself. So you have alpha cube and you have beta. I hope you get it. Alpha, let me show you. This is like alpha beta times alpha squared. The alpha and alpha multiplies, you have alpha cube, then you have your beta. That's how I got this one. The same thing you do for the other one. Alpha beta divided by 1 is alpha beta. Then alpha beta times beta square is going to give me alpha beta cube, just like the way I explained earlier. Then alpha beta divided by alpha, the alpha will cancel out, you have only beta. Beta times 1 is just beta. Then alpha beta divided by beta, the beta will cancel out, you have alpha. Alpha times 1 is alpha. So remember, you know what is alpha plus beta and you know what is alpha beta. So looking at these guys right here, you can see something is common. What is common here? You can see alpha is here and beta is here, alpha is here and beta is here. At least that's the minimum GCF we have here. So alpha beta is common here. That's the ACF here. So if I factor out alpha beta in this first term here, what will be left? You know, the alpha will cancel out, you have only alpha squared, and the beta cancels out. Then here, if alpha beta cube divide this guy, the alpha will cancel out, the beta cube will cancel out this beta, you only have beta squared. Then this guy, permit me to say alpha beta here again, is the same thing as beta alpha. Why? Because I already have alpha plus beta to be 3. Then all over alpha beta. Now it's quite long, I see. Where do I have to clean up right now? I think I need to clean up these guys first of all. Let me just clean up these guys. Then remember, we'll come back right here and do the product of the roots later on. Let's finish this one first of all. Sorry, I have to take down this stuff and yep. All right, so moving forward, let's move on. We have now, what's happening? Sorry for the delay. So now we can now further simplify this guy. But there are some identities you should know by now, which are the sum of squares and product of difference of squares. You should know all these identities by now. Sum of square is actually going to be, whenever you see alpha squared, beta squared, you can also express this as alpha plus beta all squared minus 2 alpha beta. That is how we're going to express this guy. They are identities. You should know them by now, okay? Because this is just a solution, so I can't start teaching you all from scratch right now. So you can see we already have that in this place, alpha squared, beta squared. So I'm going to replace it with this stuff right here, okay? So now let's take it up right now. So we have alpha, beta. Then all this guy becomes what I just put down, which is alpha plus beta all squared minus 2 alpha beta, right? Then we close that stuff. Then we have plus alpha plus beta all over alpha beta. The whole idea here is just to make sure everything is in the form of alpha beta, alpha plus beta, and alpha beta. That's the old stuff we are doing here. We just want to make everything be in the form of alpha plus beta or alpha beta, so that we can easily substitute all this value and get the sum of the root. Now you see we are already getting it. So alpha beta is already here, and that is 5/2. So I'll just plug 5/2 right here. Then this one, alpha plus beta, is already 3, and that is going to be 3 squared. Are we getting it? 3 squared. Then minus 2. Alpha beta is 5/2. That's going to be 5/2 right there. I hope you're getting what I'm doing here. So like that. Then we are done with this one, right? Alpha beta is 5/2. Then plus alpha beta is just 3, all divided by alpha and beta, which is 5/2. Now we go ahead and simplify. That's going to give me 5/2 into 3 squared is 9. Then these two, we cancel out these two. You have 5 minus 5 right there. Then we have plus 3, all divided by 5/2, right? Yeah. So 9 minus 5 will give me 4, right? This is going to give me 4. So, okay, let me do it them religiously. So I have 5/2 times 4, then plus 3, all divided by 5/2, right? Now 2 can divide 4, and that's 2. 5 times 2 is 10. 10 plus 3 is 13. So we have 13 now divided by 5/2, which is like saying 13 divided by 5/2, like this, right? And I can also say this is 13 times. You know, when we don't work with division side, we change the division to multiplication, and you invert this guy. So you have 2/5 here, and that's going to give me how much? 13 times 2 is, of course, that is 26/5. Wow, we've gotten the sum of the root. The sum of the root is just 26/5. So I will just come right here and say sum of root is 26/5. Remember, there's an x here. What is remaining? The product of the root. That's all. So permit me to rub off this space so that we can have enough space to clean to do the product of the root. So I think that will be fine. So 1 minute, let's do it real quick. So you can observe something. We just want to put everything in the alpha plus beta and alpha beta. That's why we are breaking down all of this stuff. So you should know identities like this: alpha squared plus beta squared. You should even know alpha cube plus beta cube. All this stuff have the identity, and I'm sure it should be in your material. I'm very sure about that. It should be in your material. So I think we have enough space now. Let's now move on to the solution. All right, so remember, we just need to just get the product of the root, and boom, we are done. That is all we need. Now let's get I think it's not properly cleaned, but we can manage. Let me just clean it properly. Oh, I can't see that space when I zoom out. Can't see that space again. All right, so let's continue from here. So to get the alpha beta, oh, this thing is taking so much time. All right, to get the product of the root, right? The product of the root. The product of root. Remember, this is the root we have, so that's going to be like alpha squared plus beta squared times alpha, 1/alpha plus 1/beta. We want to get the product of the root. So once we get that stuff, we plug it right here, okay? Just like we did for this one. So right now, let's simplify what we have in this bracket. You know, 1/alpha plus 1/beta. How do you do that again? You can just quickly say 1/alpha plus 1/beta. The LCM is going to be alpha beta. There are really short way of doing that. I don't know your level of math, so I don't want to start doing some stuff right now that you might be surprised. So let me do it the most basic way. Okay. So here you can say the LCM is alpha beta, right? Alpha beta divided by alpha will cancel out. You have beta times 1 is beta. Then alpha beta divided by beta cancels out. You have alpha, right? So permitting to say this is alpha plus beta all over alpha beta, right? So that's what we have there. So we have remember this guy, alpha squared plus beta squared. I told you what it is. It's just simply going to be alpha plus beta all squared minus 2 alpha beta, right? That is in a square bracket. Then we have these guys as already alpha plus beta all over alpha beta. I hope this is making sense right now. You can see everything is in the form alpha plus beta and alpha beta, so we can just easily substitute. Now you see the idea, the reason why we have alpha plus beta and alpha beta from this equation, because we are going to be substituting those values in these ones too. So now what is alpha plus beta? Let's take it up here. You can see here we have alpha plus beta is 3, and that is going to be 3 squared. That's going to be 3 squared. Then minus 2 alpha beta. Alpha beta is 5 over 2. That's going to be 2 times 5 over 2. All right. Then we close the bracket. That's this one. So make sure you're working with your bracket perfectly. No errors, please. Then alpha plus beta is going to be 3 over alpha beta is going to be 5 over 2. So that's 3 over 5 over 2. You see, the 3 has the bigger division side. The 5 over 2 is just a smaller one. Okay. So now let's clean up this stuff. We have 3 squared is 9. 2 cancel out. So you have minus 5 like this. Then remember, this is like saying 3 divided by 5 over 2, right? Perfect. Then 9 over 5, 9 minus 5 is just 4, right? And I told you have to change division to what? Multiplication. Remember, you have to invert the other fraction in the right-hand side. So you have 2 over 5. So now let's multiply out. So we have 4. 3 times 2 here is 6 over 5. I'm sure you know this is over 1. So 3 times 2 is 6 and over 5. So multiply out again. This is over 1 again. 4 times 6 is going to give me 24 over 5. So finally, I have the product of root and be 24 over 5 equal to 0. That is all we want. Now, just to make it look perfect, you see, we can just clean up the denominator right here, which is 5. So I can multiply both sides by 5 to take away the fraction. So that I have it as, if I multiply both sides here now by 5, I'm going to have it as 5x squared. Then if I multiply these all guys by 5, the 5 will cancel out the denominator. So I'm just left with 26x. Then this one too, we cancel out. I'm left with 24 equal to 0 times 5 is just 0. So this is the equation we want to form that has the root, this guy and this guy. It's quite a long solving, I'm sure you know that, but the whole stuff is just to understand the steps. I told you what we want to achieve. This is exactly what we want to achieve right here. We want to get the x squared minus the sum of roots and product of roots. Then I told you these are the roots. We need to get the sum. We got the sum, and we need to get the product. We got the product, right? And then we need to get the sum of roots from this equation and the product of root from this equation, which is alpha plus beta, and c beta alpha beta, which is minus b, like that. So everything I showed you the whole step. So I'm sure you got what I'm explaining here. So let's quickly go to the next question. We don't have much time. All right, this is I to the 12. We want to simplify I to the 12. Now, this one is quite very easy. This is complex number. You should know this stuff. I itself in complex number is square root of minus 1. Then I squared is going to be what? I squared is minus 1, right? I cube, what is I cube? I to the 3. Okay, let me quickly show you here. You know, I cube is going to be like I squared times I. All right, that is I cube, because from your laws of indices, you can say I squared plus 1. They have the same base. You add the powers, you still have I to the 3. So I cube is like saying I squared times I. But what is I squared? I squared, you know, is minus 1. That would be minus 1. And what is I? I don't know what is I. Just forget, please don't translate I to the square root of minus 1. Just leave it as I, okay? All right, so minus 1 times I is going to give me minus I. So here is going to be equal to minus I. Then let's do I to the 4. What do you think will be I to the 4? I to the 4, you know, it's kind of be written like I squared times I. Please, this is not 2. This is how I write I. Please manage it like that. I squared, I squared. What is I squared? That is minus 1 times minus 1. That will give me 1. All right. So you can further go to I to the 5. What is I to the 5? Just want to give you some stuff here. What is I to the 5? I to the 5 is going to be like I to the 4 times I, right? Then what is I to the 4? That's minus 1 times I. All right. And you see that's going to give me minus I. So I to the 5 is going to give me minus I. Then I to the 6, that's the last point I'm going to stop. I to the 6 is going to give me like I to the 6 is going to give me I to the 4 times I to the 2, right? Then what is I to the 4? I to the 4 already, you know, it's going to be 1. That is it right here. That is 1. And I squared is minus 1. Look at it here, minus 1. And altogether, what do we have? We have I to the 6 as 1 times minus 1 is minus 1. So that is just what you should be looking out for. These are the ways the number will continue to repeat. It's going to either be minus 1, minus I, 1, minus I, minus 1, minus 1. That is how the terms are going to be repeating. Minus 1, minus I, 1, minus I, minus 1. That is how it's going to be repeating like that. That is the that's the cycle of this I to the any power. Now let us simplify what was given to us. I to the 12. You know, I to the 12 can be written like I to the, you know what is I to the 4, right? So I can write it as I to the 4, then all to the 3. Why? Because 4 times 3 is 12. I don't know if you get what I'm trying to say here. 4 times 3 is 12. Then I definitely know what is I to the 4. I to the 4 is just simple 1. That's going to be like 1 itself. Then to the what? To the 3. And what is 1 to the 3? That's going to be 1. 1 times 1 times 1 is 1 to the 3, which is 1. So this answer is going to be 1. You can just think of many stuffs like this. So, okay, now I want you to do I to the, maybe I to the, let's say, 24. I to the 24. You can do it in your book and tell me the answer in the comment section. I to the 24. Do it in your book and tell me the answer in the comment section. Then I'll tell you if you're correct or not. All right, so you know how to go about it. Right? So you know what to do from here. The answer is just going to be easy. So just go about it. Let me tell you the answer here. So let's go to the next question without wasting so much time. Now, this is a product of complex numbers, right? Complex number. When you have a complex number, let's say x plus iy, this is the real part and this is the imaginary part. This I is like saying imaginary. So this is the imaginary part, this is the real part. But that's not what we want to do. I just want to show you that this is complex number, the real and the imaginary part. So we want to multiply these guys. But remember, what you should know that I squared is equal to minus 1. We discussed that earlier, right? So let's multiply. 5 will multiply 5 and 5 will multiply this guy. So we have 5 times 5 is 25. And 5 times 4i is going to be 20i, right? Now let's go to minus. So minus 4 times 5 will give me minus 20 I, right? And minus 4 times 4, that will give me minus 16i squared. Remember, the 4 times 4 is 16. The I times I is I squared. Oh, I just forgot something. I forgot difference of 2 squared. But let's finish up this one, then I'll show you difference of 2 squared. So you see this guy and this guy will cancel out. 20i minus 20i is 0. So I have 25 minus 16. What is I squared? That is minus 1. So here becomes minus 1. And that becomes 25. This becomes 16 times minus 1 is going to be minus 16, right? And that becomes 25 plus 16, all right? And that becomes 41, all right? Yeah. So you can also use difference of 2 square. You know, difference of 2 square is saying if you have a minus b times a plus b, the result is going to be like taking a and squaring the a minus taking b and squaring the b. That's difference of 2 squares. So I have now 5 minus 4i times 5 plus 4i. So what this is like my a and this is like my b. So I'll just take my a and square it, and I'll take my b and square it. So what's my a here? My a is 5 squared. What's my b? My b is 4i squared. So 5 squared is 25. 4i squared is 4i times 4i, which is going to give me 16i squared, right? And what is I squared? That is just minus 1. 16 times minus 1. And 16 times minus 1 will give me minus 16, right? And that will give me 25 plus 16, which is 41. The same result, right? So moving forward, let's go to question 6. Now, we are dividing complex number. Naturally, we don't literally divide complex number. Just like if you know sword, we cannot literally divide sword, so we rationalize. So that's what we are going to do. You are going to rationalize with the conjugate of the denominator. So like you know, the conjugate here is simply changing the sign that connect the two complex numbers, the two terms together. And that is like saying 1 minus 3i. The conjugate of this guy is going to be what? 1 plus 3i. Like that. So if you have 1 plus 3i, the conjugate of 1 plus 3i is going to be time 1 minus 3i, like that. So this is not what we have. We have this one. This is the conjugate. So now I know the conjugate. I'm going to multiply the numerator and the denominator with the conjugate, which is 1 plus 3i over 1 plus 3i. Now remember, this multiplies this and this multiplies this. You know that. And if you look at the denominator, we have difference of two square. Whenever you rationalize, that stuff you rationalize with becomes difference of two square. Like you can see, this is 1 minus 3i, this is 1 plus 3i. That's difference of two square, right? So let's go ahead and multiply these guys out. 3 multiply 1, you have 3. 3 multiplies 3i, you have 9i, right? Then 2i multiplies 1, that is 2i. Then 2i multiplies 3i. 2 times 3 is 6i times I is I squared. Simple. This one is difference of two square. You can go ahead and multiply straight up. It still works, but because of time, let's make it quick. So difference of two squared, this squared minus that squared, right? So my a term is like 1 here, and this is like 3i, like that. So moving forward, I have 9i plus 2i is going to give me 11i, right? Then 6i squared, no, see, I squared is minus 1. So that will be 6 times minus 1. Always remember I squared is minus 1. Then 1 squared is 1. Then 3i squared is like saying 9i squared, because 3i times 3i is going to be 9i squared. Remember, 9i squared here. There should be squared here. All right. So now let's move forward. We have 3 plus 11i. 6 times minus 1 is going to give me minus 6 all over 1 minus 9 times I squared is minus 1, right? Doing everything very basic. So 3 minus 6 will give me minus 3 plus 11i all over. This is 1. 9 times minus 1 is minus 9, and that's going to give me like minus 9, and that's 1 plus 9, which is 10, right? So that becomes minus 3 plus 11i all over 10. You can go ahead and say minus 3 over 10 plus 11 over 10i. So that is what you want to achieve. So this is the real part and this is the imaginary part. Hope you remember that. Perfect. Now let's go to the last. This is the last question here. We want to write this complex number in its polar form, right? How do we go about that? What is polar form? This is how we write a complex number in its polar form. So the polar form is going to be like this. It's going to be in the form of, let's say, r into, how do you say that again? Cos theta plus I sine theta. That is how to write a complex number in its polar form. All right. R is called the modulus, all right, or the magnitude, and theta is called the amplitude, all right, or the argument. So that is what to go about this stuff. So very basic, very basic. I want to show you how to do that. Easily to get all this stuff, you can just use your Argand diagram. You just plot this stuff in your Argand diagram. And this is like it here. This part is the real part of Z. And this part here is the imaginary part of Z. No, this is the real part and this is the imaginary part. I hope you remember. So this is my origin. So the real part is 4. 4 will be somewhere here. Let's say here is 4. And 3 will be somewhere here. Let's say here is 3. Now the point where they meet is going to be this, right? And that's the point, Z equal to 4 plus 3i, right? And that is it. So if I trace it down to this side like this, and you can see we have something here, right? This guy is our modulus, or the magnitude of the complex number. So what do you observe here? We have a triangle that is formed already here, okay? Usually, the r itself is just simply the square root of, if you have a complex number, let's say z is equal to x plus iy, for example, the modulus is just be like x squared plus y squared. But the concept of this is the Pythagoras theorem. That's how we got this stuff. So I'm only just teaching you all of these things from stuff. So I know some of you already know these formulas. You're just plugging your x squared and your y squared, get the stuff and move on. And your theta is going to be something like your tan inverse of, I think, y over x, right? So, but all these stuffs are pretty much easy to go. I'm just kind of explaining, all right? So you can just, when I've done explaining, I'll just show you how to go about it real quick. So now let's, this is r. If I bring out this triangle, this from here to here is 3. So that is 3 here. From here to here is 4. That is 4 here. So we kind of have a triangle like this. This guy is our theta. That's the argument we're looking for, theta. and here is 4, and here is 3. Of course, you know that this is r. You can just get r by doing this stuff right here, right? So r is simply going to be the square root of the real part, which is 4. That is 4 squared plus y squared, which is 3 squared. And that's going to give us 16 plus 9. And what is 16 plus 9? That's going to give us 25. And that's going to give us 5. So r is just going to be equal to 5. So I know r is 5. Now the next thing is to get the theta. What is the theta? If here is 5, you know from your normal trigonometry, you can use any of the trig function. You can use any of them. It must not only be tan. You can use any of them. But maybe we want to use tan. Tan theta is going to be what? The opposite of theta over the adjacent of theta, right? So what's the opposite of theta? The opposite of theta is 3. That would be 3. What's the adjacent of theta? That is 4. And theta itself is going to be the tan inverse of 3 over 4, right? Let me do that with my calculator. Real quick. Let's do that with calculator real quick. 1 minute. Tan inverse of, sorry. So let's get the tan inverse. That will be shift tan, then 3 over 4. 3 divided by 4. That gives me 36.86. So you can just say 36.9 if you want, 36.9 degrees. So that's our theta. And remember, they can tell you to put this stuff in radians. So this is just theta in degrees. So that's going to be like cos 36.9 degrees plus I sine 36.9 degrees. So this is the complex number in its polar form. Remember, the shortest way of doing it is to just say the modulus, which is r, tell them this is the complex number in polar form. Then the modulus is just the square root of x squared y squared. If it is written in this form, if your complex number is still in this form, your modulus is the square root of x squared plus y squared, and like that. And theta is the tan inverse of this. But all this stuff I'm doing right here, you can see that's how we get these formulas, right? You can see now for me, I can get my r. R is just square the hypotenuse, right? And that's the square root of 3 squared and 4 squared. So guys, this is just like a solution. I'm going to make a comprehensive video that will teach you all of these things we have done here, one step at a time. All right. But without saying that, just tell me how much this video has been helpful to you, so that if I'm talking too far, just let me know everything in the comment section. I'll be right there in the comment section. So thank you very much for watching. I wish you guys all the best and have a wonderful day. Bye-bye.